particle party. What is the kinetic theory of matter? All matter is made of atoms. These particles are always moving, even if it doesn't look like they are. The kinetic theory of matter states that all of the particles that make up matter are constantly in motion. Because the particles are in motion, they have kinetic energy. The faster the particles are moving, the more kinetic energy they have. While the particles of matter are constantly moving, the particles move in different directions and at different speeds. This motion is random. Therefore, the individual particles of matter have different amounts of kinetic energy. The average kinetic energy of all these particles takes into account their different random movements. As seen in this picture, solids, liquids, and gases have different average kinetic energies. So let's take a look at this graphic. We have the bridge up here. The bridge is a solid, so its particles are close together and they vibrate. In this hot pool, the liquid particles are moving around. Also, look how they are spread out. Let's continue with the graphic. The particles in the gas and the air are far apart and moving quickly. The particles in this cold river water are moving freely. How do particles move in solids, liquids, and gases? The kinetic theory of matter explains the motion of particles in solids, liquids, and gases. The particles in a solid, such as concrete, are not free to move around very much. They vibrate back and forth in the same position and are held tightly together by forces of attraction. The particles in a liquid, such as water in a pool, move much more freely than particles in a solid. They are constantly sliding around and tumbling over each other as they move. In a gas, such as the air around you, particles are far apart and move around at high speeds. Particles collide with one another, but otherwise they do not interact much. Wear your thermals. What is temperature? Each particle in an object has kinetic energy. The amount of energy these particles have can affect certain properties of the substance. As you saw on the previous page, the particles in solids, such as concrete, vibrate more slowly than the particles in liquids. This means that the water molecules in ice, which is a solid, have less average kinetic energy than the water molecules in liquid water. Temperature is a measure of the average kinetic energy of all the particles in an object or substance. The higher the average kinetic energy of the particles in the object, the higher its temperature. The temperature of an object does not depend on the type or number of particles that make up the object. Let's take a look at this graphic. This guy is pouring tea out of his thermos, warmer tea or hot tea. The tea has a higher temperature than the lake, but the lake has more thermal energy than the tea because it contains more particles. What is thermal energy? Recall that each of the particles that makes up an object has kinetic energy. Every one of these moving particles adds to the total amount of kinetic energy within an object. The thermal energy of an object is the total amount of kinetic energy present in an object. The thermal energy of an object depends on three things: the mass of the object, the number of particles, the properties of the particles making up the object, and the average kinetic energy of the particles in the object. For example, a cup of hot tea has a higher temperature than a large cold lake does, but the lake is made up of many more particles than the small volume of tea. So the total kinetic energy of the lake water is more than the total kinetic energy of the tea. Therefore, the lake has more thermal energy than the tea. What is the difference between thermal energy and temperature? Thermal energy and temperature are not the same thing. The temperature of an object is a measure of the average kinetic energy of all the particles in the object, while the thermal energy of an object is a measure of the total kinetic energy of all the particles in the object. The temperature of an object does not depend on the mass of the object, while the thermal energy the object has does depend on its mass. For example, a 10-gram sample and a 100-gram sample of a substance such as mercury may have the same temperature, but the two masses would have different thermal energies. The 100-gram sample contains more particles and therefore contains a greater amount of kinetic energy than the smaller sample. However, 10 grams of boiling mercury likely has greater thermal energy than 100 grams of room temperature mercury because of its higher temperature. Although we use the terms hot and cold to describe the temperature of things in our environment, they are not very useful terms to scientists. Measuring the average kinetic energy of the particles that make up an object is more helpful. Temperature is a quantitative measurement. Let's take a look at this visual, this graphic. The energy released as heat from the surface of objects is visualized by thermal imaging cameras. The cooler a surface, the darker the color. So notice how the darker color up top of the human and the dog, the warmer, the hotter temperatures down below. And the human's head is also a little bit warmer.